So make sure down in the corner that you've got page 27 listed. And then let's say that, I don't know if you guys have ever been to a restaurant when it's been like reserved for a certain group. Like often company parties will do that, or if you've ever been to a big family birthday party for your grandpa or something and they reserve the whole restaurant. Sometimes when they do that, they give you guys a limited meal option where you can't pick from their entire menu because they're trying to serve your whole big party, but they'll give you a limited menu. So let's say that's what's happening right now. So on the top of this paper, you're going to call this the counting principle. That's the title of this. And you can write these things down while I'm explaining what this is about. So let's say you go in for dinner and maybe it's a company party. And so there's all these, there's like 100 people there from your company, and they give you a limited menu. So on this menu, you get to choose an entree. You get to choose a side dish to go with your entree. Entree means your main dinner, main meal. And then you can choose a drink, and you can also choose a dessert. So on this limited menu, instead of listing out for you exactly what all of those entrees and side dishes and drinks and desserts are, all you really need to know to use the counting principle is how many of them are there. So let's say on this list there are 6 entrees you can choose from. You're going to choose one of those 6 entrees, and sometimes, I don't know if you've ever been to a place where they give you crayons and they have you write on the tablecloth which one, or circle which one you're choosing or something like that. But you're going to choose one of these 6 entrees, you're going to choose one of the 5 side dishes, and you're going to choose one of the 4 drinks, and you get to choose one of the 3 desserts. Now here is my question for you, and I'm going to write this as question 1 right here. If these are your options in this limited menu, my first question is, how many possible meal combinations are there? And we started to kind of look at this when we were making lists and tables, but please remember that it's not so simple as just, the biggest mistake students make is they want to just add all these up. And they want to say, well, if there's 6 entrees, then 4 drinks, that's 10, 15, 16, 17, there's 18 possibilities, right? Well, if you imagine starting to make a list on this, if you started to look at this and started to list it out like we did last time, where we went, you realize that there's actually a lot more than that, because if there's 6 entrees, let's say one of the entrees is, I don't know, lemon chicken. Okay, so let's say one of the entrees is lemon chicken. Well, you can pick lemon chicken, and then you can pick one of the side dishes, and you can pick one of the drinks, and you can pick one of the desserts. If all I do is change the dessert and all 3 of these stay the same, that's a whole new combination. So lemon chicken is going to be 6 times, but with all the 5 side dishes and all the 4 drinks and all the 3 desserts, this is not an addition scenario. The counting principle is all about multiplication. Okay, so the counting principle, in fact, I'm going to put this word up here next to the title so that we know and we don't forget. Counting principle is always multiply. And the question is, multiply what? Well, multiply all of your possibilities. Okay, so if I have, so I'm going to write down here, here's how I would respond to this. I'm not going to add up those numbers. I'm going to multiply them. So if I have 6 entrees, then I do 6 times the 5 possible side dishes times the 4 possibilities for the drink times the 3 possibilities for the dessert. This is going to be a lot more options than we originally think. So if I type this in here, I'm going to do 6 times 5 times 4 times 3. And there are actually 360 meal possibilities. 360, we're going to call them outcomes. 360 possible meals, and any one that I might pick. I'm going to do lemon chicken with steamed broccoli with Sprite and chocolate cake. That is only one out of 360 possible outcomes. Now you can imagine if there are 360 outcomes, do you want to make a list with 360 values in it? I do not either. Okay, so the nice thing about the counting principle is that it immediately gets you to how many options are there. Hi, Penelope. So I can't see exactly what all those combinations are, but sometimes your only concern is how many are there. Because now they could ask this. Let's do question number 2 in this one. Now they could say, what is the probability? Okay, this is how it connects back into probability. If I now know the outcomes, then I can answer a probability question. What is the probability that you will choose one specific meal combo? I'm just going to write combo instead of combination. So the probability that you will choose one of these, which is what's going to happen, but the probability that it will be any one specific out of your 360 options is precisely that. We're going to go 1 out of all of my, I'm going to pick 1 out of the 360. So if you wanted to try and guess which one I'm going to pick, the probability that you would be correct is only 1 out of 360. 1 divided by 360, when I type that in, look at this decimal that I get here. So I'm going to write it as a decimal. I'm going to put equals 0.00, and I'm going to round that 2 to a 3 because it's 27. And then if I want to change that to a percent, I go times 100, and that is less than 1%. That's what that means. That means we are only, if you wanted to try and guess, before I pick anything, if you wanted to try and guess exactly which meal combination I'm going to pick, you would only have a 0.3% probability of being correct, because there are 360 total possibilities. Okay, let's organize this a little bit so that our notes make sense later when we look at them. So I'm going to draw with blue here, I'm going to draw a blue squiggly line to separate this out. And then I'm going to put a little title over here so I know this part was all about a restaurant menu. And you'll see next time you're at a restaurant, you can take a look at all the options there. You can go through and go, okay, here's all the entrees, and you can count them up. Here's all the possible drinks, and you can count them up. Here's all the desserts, and you can count them up. And if you just times all of those options, you'll see that most standard menus actually have way more than 360 possibilities. But the counting principle is all about multiplying these. Okay, let's look at another example, because I feel like with the counting principle, the idea is simple. We just need lots of examples to prove to us what's going on. So let's say right now you're home and maybe you're doing a lot of what we've been doing at my house, where we're cleaning out different closets and cleaning out rooms, in our case, because our basement is finished. So we're moving a lot of stuff down there and cleaning up a lot of stuff up here. But let's say you're going through your closet, because it's getting warmer too, and let's say you're putting away a lot of your winter clothes and you're getting out a lot of your spring and summer clothes. And you find that some things don't fit you anymore and some things do. And what you have left right now is you have, I'm just going to put right here in green, you have 8 shirts that fit you and are good for warmer weather. You have 5 pairs of shorts that you like for warmer weather. And let's say you have 4 pairs of sandals that still fit you and are going to be great for the warmer weather. Okay, so my question is, if you know that's what's in your closet, you've cleaned everything else out, and you're like, okay, I have 8 shirts, I have 5 shorts, I have 4 sandals, here they all right here. We can use the counting principle to figure out how many possible outfits can you create just with this information. Now, obviously, you're only going to wear 1 shirt at a time, 1 pair of shorts at a time, and 1 pair of sandals at a time. So then the question is, if I pick a shirt and I pick some shorts and I pick some sandals, that makes 1 outfit. How many total outfits can I have if these are my options? Well, what's the big keyword we wrote up here? Everybody tell me, what do we write there? Multiply, right? We multiply all of our possibilities there. So that's what I'm going to do here. I'm going to say, okay, I have 8 shirts, I have 5 shorts, I have 4 pairs of sandals. 8 times 5 times 4 means, that may not have sounded like a ton to you to start, but that's actually 160 possible outfits. 160 just from those. And you can imagine if you started bringing other things in, if you're like, okay, what if I have I buy 2 more shirts and now I have 10 shirts. That changes this value and makes a lot more possible combinations. So that is just how many possible. And if I wanted to try and guess which specific combo you were going to put together, I would ask this. I'm going to put it this way with our probability notation. What is the probability that you will choose one specific outfit combination? Out of those options you have, what is the probability that I could guess the one that you're going to wear? Well, that probability would just be 1 out of 160. Okay, 1 divided by 160 gives me this decimal here. I'm going to write the whole thing just because it terminates. And even if I times that by 100, that is still less than 1%. Not a very high probability. The more options you have, the less likely it is that I can guess the one that you're going to choose. So let's organize this. I'm going to show you one more example. Actually, a few more examples, but we're going to call this one picking an outfit. So we have a little title and know what it means later. So we've seen an example of how you could see how many options you have picking from a menu, how many options you have for picking an outfit. What if we just think about playing a game? Okay, let's say that in this game, you roll 2 dice. Have you ever played a game like that? Where you have 2 dice and you have to roll both of them? And you have to roll the 2 dice in order to move in the game. Just 2 dice. Okay, well, let's think about how we could use the counting principle to answer this question. Okay, how many, so I'm going to call this question 1 under here. We're going to say, how many possible combinations are there? And I'm going to give you an example to show you what I mean. So if you're rolling 2 dice, the idea would be this: how many possible combinations, meaning, and I'm going to put this in parentheses, for example, one combination could be if you roll 2 dice, maybe one of them is a 1 and the other one is a 6. That's an example of what I mean by the combinations. You could get a 1 and a 6, you could get a 1 and a 1, you could get a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6. You could get a 2 and a 1, a 2 and a 2, and we can make a whole table out of that. We can make a list out of that, but actually we can really easily just use the counting principle. So the 2 events here are die number 1 and die number 2. So tell me, for a single die, how many options are there? We've talked about this one a ton. There are 6 possibilities on the first die, and there are 6 possibilities on the second. And because you're rolling 2 of them, you just have to do 6 times 6. 2 events, 1 die and the other die. 2 dice, 2 events. If you're playing a game where you were rolling 3 dice, you'd have 6 times 6 times 6. Is this making sense? If you're playing one of those crazy games that actually had like a 12-sided number cube, we wouldn't call it a number cube, but a 12-sided die, then you'd have 12 options, okay? So 6 times 6 is just 36 outcomes. And when I do this in class, students always want to tell me that if I'm rolling 2 dice, then I just have 12 outcomes. You are not adding. Remember, the key word here with the counting principle is multiply. 6 times 6 is 36. So you have 36 outcomes. Now let me ask you a couple probability questions for this one, okay? So question number 2. What is the probability? I'm going to pick one specific. Let's say in order to win this game, you have to, you need to get, you know those games where you're like 2 away from the end and you have to get the exact number of spaces? So let's say you're 2 away from the end and you need to roll a 2. Well, the only way to do that, if you have to roll both dice, is you have to roll double ones. So let's say, what is the probability of rolling double ones? Rolling double ones is one specific outcome for out of all 36. A double one, a 1 and a 1, is one outcome out of 36. Does that make sense? That's not 2 different outcomes. That is one specific overall. It's one roll, a 1 and a 1, 1 out of 36. So 1 divided by 36 equals 0. It says 0.2777, so I'm going to write 0.03. That's a decimal. I'm going to times by 100, and that means I only have about a 3% chance of getting that. So if I have to roll double ones to win, I only have a 3% chance of getting that. That's why those games are difficult to actually win. You get to the end and you're like, I'm almost there. But if you have to get the exact amount to win, it can still take forever because the probability of getting that exact amount is pretty small. It's only 1 out of 36. So what if you just had, what if you're playing a different kind of game and it wasn't a certain number of spaces you had to win, but let's say you had to just roll any double. And there are some games that when you roll doubles, special things happen. So let's find out what is the probability of rolling any doubles. So let's think about how many options we have there. Well, if you're going to roll a double, it's got to be double ones, double twos, double threes, fours, fives, or sixes. Those are your options. That's 6 possible or 6 successful outcomes out of 36. It's still out of 36. We use the counting principle to find that. 6 out of 36 is 1/6. So I can type in my calculator 1 divided by 6, which gives me 0.1 and then a bunch of sixes. So I'm going to round to that. If I times by 100, that is a 17% chance. Still not huge on our probability scale. That would be down on the unlikely side of things. But it's certainly more likely to win if all you have to do is roll a double than if you have to roll a specific double. Okay. So let's organize this, and then I'm just going to give you a couple more examples that show in real life how this idea of the counting principle is used and is helpful. Okay, so I'm going to call this one playing a game. And then these last ones, this whole last section is going to be called, so I'm going to write it over here. It's going to be called real life. Not that playing a game and going to a restaurant is not real life, but here's some more real life uses to the counting principle. Okay, first I'm going to tell you this. Have you ever been like on a road trip or something? And have you ever played like the alphabet game where you'd have to find things that start with A or B or C? And I find license plates are always really helpful, especially if you get on a stretch road where there's not very many signs, there's not very many buildings. You have to rely on license plates to help you with that because license plates do have letters. But they also have numbers. So if you didn't know this, Utah license plates have a pattern. Okay, so first of all, you need to know what that pattern is. Okay, so the current newer license plates, the patterns go like this. They have a letter, and then a number, and then a number, and those are the first 3, and then there's a space in between, but the space doesn't really matter for our options. There's a letter, number, number, and then the other 3 go number first, and then letter, letter. This is not always how it was organized, and I'll talk to you about why it changed in just a second. But this is actually 6 different events. The first event is that first letter. The second event is the number. The third event is the number. So this is technically 6 different events. Now, I could ask you to make a list of all of the possible license plates we could have in Utah, but that would get really tedious really fast. So instead, we're going to use the counting principle to answer this very important question. How many possible license plate with an S. How many possible license plates can we have in Utah? If that's the pattern that they go, watch how the counting principle can help us figure this out. And let me just start with this question. Do you think we care how many possible there are? Does it matter? Well, you have to ask yourself, what's the purpose of a license plate? And a license plate is part of how that car is registered to you, and it identifies you as the driver and the owner of that car. So we really need to be able to have 1 license plate per car. They need to be unique, okay? So actually, I'm going to add this word to, I'm going to put in parentheses, unique license plates. Unique means you have a license plate for your car and you are the only one that has that license plate. It would be a real problem if a bunch of us all had the same license plate numbers. And they call them license plate numbers even though there's letters on them. Anyway, but it would be a problem if more than one of us had the same license plate. They need to be unique to you and to your car. So this question is, how many of them can we get with this pattern? Letter, number, 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 letter, letter. So let's go to each event and let's ask ourselves, what are the possibilities here? The first spot is a letter. Well, in our English alphabet, how many options is that? How many letters are in the alphabet? 26. So for that first spot, there are 26 possibilities. And I'm going to use a dot for multiply so that we remember that is a multiplication symbol as well, dot or X. Now the second spot is a number, and that's only a single spot, so it's got to be a single digit. Now you can have zeros. I'm sure you've seen plenty of zeros in license plates. So that gives us these options: 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And because 0 is included, that actually gives us 10 possibilities. So this number could be 10. This number, the number itself couldn't be 10. There are 10 possibilities there. This number is also 10 possibilities. This number is also 10 possibilities. This letter is 26 possibilities, and this letter is 26 possibilities. This is why we throw letters in with our numbers on things. It gives us way more possible combinations. So if I type all this in, 26 times 10 times 10 times 10 times 26 times 26, look at that number. If I put my commas in to help me with the place values, this number is actually 17,576,000 possibilities. That is how many possible license plates we can have in Utah. Now, when I was a kid, the license plates actually followed a different pattern. They went, I don't remember which one was first, but all the numbers, it went like number, 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 or letter, letter, letter. Now that actually did not, if you can see if I move these around, that would have just been like 10 times 10 times 10 times 26 times. It didn't actually change the amount of possibilities in that. But if you move where the letters are placed, that does give you, it does actually double the amount of new license plates you can make, because it does make it unique now that letters are in different places. So we have right now about 2 million registered drivers in Utah. Some people have multiple cars, or some people, you have a car for a while and then you get a new car and you need a unique license plate for that, or you can, anyway, you can move your license plates, I think. I don't know. Anyhow, this is an important amount for us because we need to make sure we have plenty of unique license plates for all of the people we have driving cars. Now, one more real life example that might apply a little more to you because you guys don't drive. Some of you do have a phone though. So let's say you have a phone, and when you have a phone, isn't there usually like a locking code or something you need to type in so not just anybody anywhere can pick up your phone? Let's say you just have the most basic option, okay? So on your phone, let's say that your phone has a 4-digit code. Now, you might have more than that on yours, and you'll start to see as we go through this why that becomes an option. But if your phone has a 4-digit code, and I'm going to call this number 2 since we're still in this real life uses category, the first thing I want to know is how many possible codes are there? If you're going to pick a 4-digit code, like obviously, and we could list them all. You could just do 0000. That's one possibility. You could do 0001, 0002, 0003, 0004. And you can imagine now as I start naming those out, just how long this list could be. It could get really bonkers really fast. So let's use the counting principle to help us. If it's a 4-digit code, that's going to be like the license plates. If you look on my calculator here, these are the numbers you can use on your phone as well. And that's why there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 possibilities because you can use a 0. Okay, so digit number 1 has 10 possibilities. Digit number 2 has 10 possibilities. Digit number 3 has 10 possibilities. And digit number 4 has 10 possibilities. And if I type in my calculator 10 times 10 times 10 times 10, guess what? That gives me 10,000 possible codes. So even if you just do a basic 4-digit code, there are 10,000 possibilities. So here's an important question. What is the probability? What is the probability? Probability that someone, let's say someone just picks up your phone and tries to guess your code. What is the probability that someone will guess your specific code? If there are 10,000 possible codes, the probability that they will just pick up your phone and correctly guess yours is 1 out of 10,000. 1 out of 10,000 is 0.0001, which is 0.01%. That is only 1/100th of a percent. Is it very likely that someone can just pick up your phone and guess your code? No. Now, could they possibly sit there and type in all 10,000 codes if they really, really wanted to get in there? If they did that, would they eventually guess your code? Yeah, if they could sit there and go 0000, 0001, 0002, 0003, and they would eventually get this, which is exactly why, what happens if you type in the wrong code too many times? What does your phone do? It locks you out. And this is exactly why. It's so that somebody can't just sit there and guess all 10,000 codes and get into your phone. Now, what also, many of you might have pattern codes, or you might have, instead of only 4 digits, maybe you have 6 digits. And the more numbers you add there, the more patterns you do, the more possibilities you get, the more outcomes there are, and the less likely it is for somebody to be able to guess it. All right, so the counting principle is actually a really useful thing that we use a lot to help us figure out how many possibilities there are. And along with that, as soon as you know the outcomes, you can also get probabilities. So that is what you're going to practice on your MLE. Of course, if you have any questions, please let me know. And I'll see you next time. Bye.